So welcome everyone to today's TAM Lab. It's TAM Lab 85 and it's EMEA based. And the topic is Federation setup using NSX-T 3.1 and use cases. Our presenters today are Bassem, TAM from the Netherlands, and Pep, TAM colleague from Spain. TAM customers, if you watch this video and if you are interested in sharing ideas with us, reach out to your TAM and we'll get something up and running. And also, very important reminder, Adobe Flash Player is end of life December 31st. Work with your TAM, understand what potential impact this has on your infrastructure. And with this, I stop sharing and hand over to Pep and Bassem.
Thanks, Tina.
Thanks, Tina. Let me share my desktop. So I assume that you can see my desktop right now.
We can.
Yeah.
Thank you.
Perfect. So yes, thanks Tina and James. Good morning, everyone. My name is Pep and I'm a senior VCM TAM. I joined VMware 3 years ago and I'm part of the Iberia TAM team, as Tina said. Along with me, I have my mate, Bassem, all of yours, if you want to do a quick introduction.
Yeah, thanks, Pep. My name is Bassem, and I'm a senior VCM TAM, and I joined the same time as Pep, so also 2 years with VMware, and I'm based in the Netherlands. And together with Pep, we'll walk you through the lab for NSX-T Federation networking and security use cases.
So yes, thanks, Bassem. So on this TAM Lab, we will show you NSX Federation and the two main use cases. On the first hand, networking across locations, and on the second hand, security with distributed firewall and security groups. So yes, this is the agenda for today. We'll begin with a brief overview of Federation components and management flows. Then we will move forward with use cases, first reviewing the theory and second a demo on each one. Bassem will drive the demo of network use cases and I'll drive the security demo. And finally, if we have time, we'll review very quick the Federation requirements and we'll see some main designs. Please, at any time, if you have any DAP question, feel free to interrupt us. As usual, don't be shy, right? So yes, let's start. So let's start with Federation components, right? For those you are not familiar with this concept with NSX, this is the way we have to talk about multi-site architectures where network and security are spanned across NSX domains. You may already know NSX Cross vCenter, the multi-site solution with NSXB. So Federation, it's similar, but with NSX-T, right? So imagine that you have 3 locations. On each location, you have the components called NSX-T Local Manager. So no changes so far. Those are the management cluster we already know today. And at that point appears a new concept called Global Manager Cluster. And for example, we can deploy it in location 1, as you can see here. At the same time, you have the ability to protect this cluster with a standby Global Manager cluster, for example, deployed here in the location 2. And finally, we register local managers against the Global Manager. Right? At that point, we can see that our NSX Federation is up and running. Okay. So how does communications flows work between global manager and local manager? For instance, a user can configure directly on global manager, and then that configuration is pushed to the local manager. Imagine you want to create this scenario, right? A standard multi-tier configuration across 2 locations. So you create a configuration at the global manager level. It's replicated to the standby global manager, as you can see. And that configuration is automatically pushed to the location 1 and location 2. Take a look at the fact that this configuration applies only on location 1 and location 2. Location 3 will never be aware of that configuration. So what happened with the communication between local manager? Imagine you create a security group which spans multiple locations. This configuration is replicated to all sites, as you can see. Each site will group its VMs, and at the same time, they will notify other sites in order to have a list of all VMs within this group, on all sites, regardless the placement of the VMs. So in terms, I understand that no questions so far, so please interrupt me if you have anyone. In terms of Federation UI, the new concept called location manager is introduced, and on the top of the UI, we have a location drop-down menu where we can choose the UI of any location at any time. So if we select the global manager, we will see a status overview of the federation, active and standby global manager details, and the details of the locations, specifically for every location. So finishing that section, I would like to highlight that regardless on those designs where we have in place the global manager, we still have the ability to configure our NSX-T directly against a local manager. So the key point here is that, sorry, I have to go back one here. The key point here is the local configuration created on global manager, as you can see here, is pushed down to a local manager. But if it's not the same when you create the local configuration directly on the local managers, because this configuration, it never will pull it up to the global manager. So it's important to keep in mind that point. So let's jump to the use case and demos. Bassem, all yours.
Yeah, thanks, Pep.
I'm gonna stop sharing.
Yeah, thank you. I'm going to quickly share the slides from my end. So share screen. So I believe you can also see my screen.
Yes.
So so thanks, Pep. Quickly commenting on Pep's introduction to Federation. The main use case for Federation, I think, or the ask for Federation was to provide a feature where you can have consistent networking and policy configurations across different sites. So, for example, here in the lab, we'll make you, and in the slides before that Pep was talking about, we have the concept of stretched T0, Tier 1s objects that can be imported between the local VM, local managers and the global managers. So if you create an object in a global manager, you can choose under which site those objects will be created. Think about the distributed firewall rules, security groups, tier 0, tier 1s that spans different sites. So that's the main use case for federations, basically, to ensure consistent configuration across multiple sites. At the moment, quickly about the limitation, we support 3 sites only at the moment. So you can have 3 local managers managed by a global manager cluster. We do not support at the moment VMC on AWS, for example. This will come. Federation with VCF is also an open topic at the moment because there is a quite of ask now to have kind of a link between federations and VCF. So back to our lab. Here, I'm a horrible user when it comes to Visio. So as you can see, it's a very poor Visio diagram. But it will just give you the idea of the lab, of what we have here. Let's see if I can expand it a bit. So the lab that we have will start by configuring the global manager. I'll be using just one global manager. But of course, in a production environment, it's recommended to have a cluster. We call it an Almere, which is the site where we'll have the global manager in. Then we'll be provisioning 2 sites, 2 LMs, one called Amsterdam and the other is called Utrecht. And this is where we are going to have our 2 sites managed by the global manager. Then we will be creating stretched T0, which will have a BGP peering session with an external router here. And stretched T1 as well, which is also will be connected to T0. Of course, we need to have edges. This is, I mean, it's just a basic NSX setup. You'll always have edges for your north-south connectivity. You need edges. Of course, and then you will be configuring a stretched logical segment. And when I say stretched T1, T0 logic segments, I mean it will be spanning the 2 sites that we have. So when we, from the global manager, will be creating the logical segment, you will see in the lab that it will be automatically created on the 2 sites. The same applies for the T1 and the T0. This is here the subnet that we are making use of for the logical segment. And the whole idea of the first lab, which is setting up the federation and the basic networking connectivity, is to build up the global managers, the 2 sites, edges. You'll just see them. I don't need to show you how to create edges. It's a basic NSX concept. Has nothing to do with federations. We'll be creating what we call a remote tunnel endpoint, which is a new concept in federation, and you need this remote tunnel between the 2 sites if you want to have this concept of stretch. So if you need to have an inter-site communication, then you need to have the RTEPs or the remote tunnel endpoints configured. And once we set up the basic federation, which is setting up the GM, setting up the local managers, I already have Amsterdam configured. I'll be just showing you how you add Utrecht. It's same concept, so it doesn't really matter. There is no need to see both of them. And then once we set up the basic federation setup, I'll show you how you create the T0, the stretch, the tier 1s, the logical segments, and also how to create this BGP peering. Yes, so here we have some videos. I'm going to share the first video, which is setting up the basic federation, and we're starting by setting up the global manager. Setting up the global manager it's something that you need to do while you install the NSX manager from the beginning. If you set up your NSX manager the default way through an OVA, it will not be installed as a global manager. It will be installed as an LM, and you cannot convert it to global manager. So you have from the beginning, while you deploy it, let's see it here, choose the role as a global manager. So if you click here, if you click play, so this is choosing deploying from the OVA. Giving a name, this one will call it NSX Global Manager, and then you pick the OVA. It must be 3.1 where, well, must, but because it's where the federation is production ready, is in 3.1, just basic connectivity. And this is also very traditional or standard setup for NSX-T, nothing special so far. Setting up the root user passwords and the same for admin. And after this one, you will see the only change. Well, yeah, network properties. Here you give it just a host name. We'll call it this one. And here comes the only thing that you need to take care of. Yes. So you have to change to choose the role here to be global manager. If you don't do this and you install it normally, it will be installed as a local manager. So yeah, this is the only thing that's different that's related to federation. And you just here you do the rest of your networking configuration. And then you click on finish. So this was setting up the global manager. Let me now show you the next steps, which is setting up the federation and adding a local manager site. Let me do a new share. Yes, this one. Now, it's configured. So we have the IP address, or here I use the fully qualified domain name, NSXGM. It's more illustrative. Yeah, just take some time. I'll just pause the video here. So just pause it quickly. So this is what we're using. Sorry, we're using the basic version of the the free version. So I have to. Yes, so this is what Pep was highlighting here. I actually jumped a step ahead. If you log in for the first time, you'll just need to set up the site, the global manager site. So here I created the global manager called Almira. So this is the only thing that was not shown here in the video, but it's very straightforward. If you log into with the fully qualified domain name or IP, you'll be able to set up the site. So yeah, here just show you the bit of the configuration. If you see here the global manager site. If you go to system, and you'll find only the global manager appliances location manager only if you set up the system as a global manager. You can just ignore this yellow wording. Should be green, but in the next videos will be green. It's just because the sorry, I'll just need to pause this because here I had the monitoring service daemon was down in the NSX manager appliance. I just had to reboot it to be up again. So you'll see this green in the next videos. This just to show you, just to tell you why this was yellow. You see here the remote tunnel endpoint status is unknown, basically because we didn't set up the next site, so it's not configured. So that's why you see it as an unknown. There was a bug in NSX-T 302 or 301 or 30, yeah, something like that. When anyway, Federation was not yet production ready, where even after configuration, you will see it as unknown. You had to do, I believe, a couple of refreshes or re-add the site, something like that. But it's not from 3.1, it's resolved, so I didn't need to worry about it. So continuing the video, we'll need now to add the second site. So if you go to Location Manager, you'll see the option where you can see add on-prem location. So this is the location name, and you can give the IP address or the fully qualified domain name of your local manager, and this of course need to be configured from the beginning. And then you enter the password of the local manager, and this one you need to get it from the local manager itself. So if you can see here, we log into the Utrecht local manager. I mean, when I say local manager, it's just an NSX-T manager instance. Huh? So the local manager itself doesn't have any idea about a global manager in a way. And this is how we can get the UUID needed, the thumbnail needed in order to add the local manager. So you go here for the details of the local appliance and the certificate thumbprint. Sorry, you copy it, you go back, and this is what you need. And you see it's compatible with 3.1. And you can see here, just you need to save it. It will take some time. And once the site is added, you can import the configuration of the site into the global manager if you want. And there's a list where of the supported configuration that can be imported. This alert, it happens. I am not sure if this is a bug or a known behavior. I have to check it, but it tells you there is no default transport zone not found, but it's there. So it will just take a couple of refreshes and then it will go away. Or sometimes I had to just change the default transport zone for the VLAN and the overlay and just set them back and then it's resolved. But it just takes some time and it will go on its own. So you just don't need to worry about that. So the next step, we need to configure the RTAPs, the remote tunnel endpoints between the two sites. So if you click on configure, now you see you pick the edge because it's between the two edges. You pick on which edge switch you have you want to configure it. I created an RTAP NVDS for that. You pick a VLAN that you want to use. It must be different than the taps, of course. you pick the IP pool that you want to use. So this is configured for Amsterdam. I could have also jumped to Utrecht right away, but I just want to show you here how you initiate it from the global manager. So you click again on networking, but now for the Utrecht side. So yeah, this one looks like the tunnel was already configured on the edges, because when I removed it, I did not reconfigure the edges. The edge maintained basically the tunnel configuration. So here I was clearly showing that I forgot that already the tunnel exists on the edge. That's why I was keeping on refreshing. But I'll show you now, if you go to the Utrecht, you'll see that the edge was already configured with the RTAP. Yeah, see, it was already configured because the RTAP configuration is maintained on the edges, and I was had the lab already configured and tested many times before the recording. So when I removed the Federation config, I forgot to remove the RTAP config from the edge, and that's why it's already there. But it should now be up. It will take some time, a couple of refreshes, and then it's basically a BGP session that needs to be established between the two edges on the two sides. That's normal. It will take some time to come up. Couple of refreshes, and see here. Both RTAPs are up on both sides. And this is only you only need RTAP if you want to configure to establish inter-site connectivity between the two sides of your local manager. And it's just to verify the tunnels. Again, they are created on your edges. You can also verify if you later want to change any config of the RTAP, you have to do it from here, from the edge configuration, as you can see here. And you see below here, it's established session. It's a BGP session between the two sides. And you can see the name of the other side. And the same in Utrecht as well. You can see also the information from Amsterdam. So this is basically it. This is the basic setup of the two sites. Let's now moving to setting up the T0s and the BGP peering. Share my screen. From now on, it's going to be kind of standard NSX T0 setup, kind of. So the only new concept that you should here see, if you have never seen Federation before, is just when you configure the uplinks and the VLANs that you have to do this. You have to select the site on which you want to create a particular segment or a VLAN. But as a concept of setting up a T0 and uplinks, it's exactly the same as any traditional NSX-T setup. So playing the video from the global manager, and yeah, sorry, one point. If you want to configure anything related to Federation, meaning that you want to configure an object that will be applied on both sides, you have to do it from the global manager. Otherwise, it will not be replicated. So if I create a logical segment on Amsterdam, then it will not be replicated. So whatever you create on an LM stays in an LM. But whatever you create in a GM and you choose the two sites will be propagated to all the sites under that GM. So you have to make sure that when you do your configuration, the stretched configuration, you have to do it all from the global manager. That's why here we access the global manager. So the first step will be basically creating the uplink segments that we have. So if you check the lab topology, we had two uplinks, VLAN 10 and VLAN 20, connecting to the external routers. And this is, I'm creating the first VLAN 10, which I'm going to use for the first uplink. And this will be from Amsterdam side. I'm going to use the VLAN transport zone because it's a VLAN based traffic. And here it's a VLAN 10. And it's just a layer 2 segment. So you don't need to just do anything more than this. And we do create the same for uplink VLAN 20 underside Utrecht. So these are the two uplinks for the stretch T0 gateway. The second step now that we'll do after this is creating the actual Tier 0 gateway and assign these two uplinks. So just check status to make sure that they are all synced with the GM. So both are success and both are sent to the LMs as well. You go to the T0 gateway, you add a Tier 0 gateway, give it an name T0 stretched. We will have it active. Active mode, both sites are active. And you can see just here add location because we need to have it on both sides. You pick the edge cluster because it's the uplinks, basically. It's north-south for T0, so yeah. So it will span these two locations. Then we need to save it. And then this is just the T0 you have now to identify or to add both uplinks that we just created, both interfaces. So yes, we need to continue configuring the T0. Then now you can see that interfaces is now enabled. You need to set them. So add the first interface, which will be on the Amsterdam site for uplink 10. So we call it uplink 10 or uplink 1 for VLAN 10. Sorry. And here we need to give it an IP address because we're going to use this interface to peer with the BGP neighbor, the external neighbor. And I have only one edge under Amsterdam. And then we create an uplink 2, the second uplink, which is VLAN 20 under Utrecht. And you can see these segments already that we created appear, and we can select them. We check status quickly to make sure that the configuration successfully propagated to both LMs. Both are successful. One step here further is we need to enable routing and route distribution, basically, to make sure that the BGP, of course, that's what I meant by routing. We have here autonomous system 65000. We use it here, and then we need to set up the neighbors. So we basically, I have one external VYOS router with two interfaces, one in VLAN 10, one in VLAN 20. And here we're setting the IP of the neighbor interfaces. 150 is for Amsterdam and autonomous system 65030. And the source address, we have already one address. So that's, yeah, for VLAN 10. And need to do the same for the second neighbor through Utrecht. Checking status. Checking the status is only config, just to tell that the config has been propagated. It doesn't say that the neighbors are up. So it's just to say that the configuration has successfully been propagated to both sides. This is now checking the neighbor relationship. This is the external router. You see now both are up. As long as here you see numbers, you don't see active or idle, means that they are established, because session status in BGP must be established. Zeros here means zero routing BGP updates has been received. So, but means the neighbors are up, but haven't yet sent any updates. In the next video, what we're going to see, we are going to create the tier 1 subnets, the logical segments, and we are going to redistribute those logical segments through BGP to the external router. So moving here, this one. Yes, share screen. Yeah, now, so playing this one. So as we said here, we're going to start creating the tier 1s and enable route distribution. Route redistribution is important so that the external world, in our case here, the VY OS, needs to know about your connected segments for tier 0 and tier 1s. So here we enable route distribution for site Amsterdam, and we need to do the same one for Utrecht. So also the routes, whatever will be routing configuration in Utrecht and Amsterdam would be propagated to the external world. It's not a must, of course, but this depends on what you need to do. If this is part of North netting configuration, or if you require external access to your logical segment, then you have to enable route distribution. Yeah, checking the status of the config. No success. Now, second step now is creating your tier 1 gateway, which would be connecting it to the tier 0. And then eventually the stretched segment, we call it tier 1 stretched. We connect it to tier 0 stretched. Locations, we have already the configuration here on Amsterdam and Utrecht, because this is where tier 0 is configured. We enable route advertisements between the tier 1 and tier 0, and we just save it. We don't need to configure anything further, and just check the status. Looks good. Now, the last step will be creating the stretched web logical segment, to which we will be hooking up our 2 web server VMs under the 2 sites, and then test connectivity between the 2 sites. So we call it web ls stretched because it spans the 2 sites. We connect it to the tier 1, and here we give the subnet, which would be the gateway for this logical segment. Basically, this is the IP that will be instantiated or configured on your tier 1. And it uses now, of course, overlay, but it has already automatically been picked up. And I have to say, for this lab, I'm using vSphere 7 converged VDS, so we will be able to view the stretched logical segments right away from our vSphere VDS configs. So this is where I'm going now to switch to the vSphere. And we're going to show you the last step, which is verifying the web logical segment from vSphere and testing connectivity, layer 2 connectivity between the 2 sites.
Cheers, Bassem. And just to confirm, you need vSphere 7 and NSX-T3 for this, don't you?
Of course, yes. So to be able to make use of the converged VDS, you need to have vSphere 7 installed, and before that you need to upgrade, because by default vSphere 7 will get you VDS 6.6 or 6.5. You have to first upgrade the VDS as well before you can make use of this.
Yes, of course, yeah.
Yeah. I don't know why I'm not seeing the video. Let me do one thing here. Yeah, now I'll just reopen it again. Okay. Okay, now let me share it. Share screen. Yes, that's the one. So here we'll be verifying that the stretched logical segment has been created. under the vSphere VDS, converged VDS, and we'll be testing layer 2 connectivity between these two VMs after we connect them to the web logical stretched logical segment. And all this communication will happen through the enter site connectivity, the RTAPs, because it's an enter site connectivity. It's purely layer 2. I mean, not purely because there is encapsulations happening, but you get my idea. It's just pinging two VMs under the same subnet.
Absolutely.
So these are, you see now, this is the default connectivity which I have. So we have to change them first to hook them up to the right. See here, if you browse for it, you'll see now the web which we created with a small n, hinting that it's an NSX port group. We need to do the same for the web 01 under Utrecht. And you see that it was saying the VDS is the VDS, so it uses the traditional one. And if you go here to networking, see it's created directly under your VDS. And if you click on it, you can now see to which hosts and configuration. It's just as any traditional port group or standard port group, sorry. Now testing the ping. I just decided to open the two sessions first before testing the ping. Verifying the IP address first of the virtual machine. It has the 172.16.20.2, which is the subnet that we gave or configured under the web logical segment and the tier 1 interface. This is .3, which is in the Utrecht site. And just now we need to ping, here. So it can reach the 20.2. And here pinging the gateway, which is the tier 1 interface. So that was basically it. That was the basic networking setup for Federation, and you can do all the configs then based on this concept where you can create objects on the distributed firewall, on the global manager. Think of security groups, distributed firewalls, networking configuration segments, and this all will be propagated, through the global manager to all the sites. By this, and I hand over back to Pep. Pep, floor is all yours.
Thanks, Bassem. Let me share again my screen. Hopefully, you see my deck.
We can. Thank you.
Cool. So thanks, Bassem. On the following section, we'll review the security use cases, right? So it's very simple, but at the same time, it's very powerful because you have the ability to configure everything from Global Manager, as you've seen with Bassem's lab, and the workloads. It's able to move between locations, keeping the security in place. So imagine that you have a DR, you have an active data centers, so you are able to move the workloads. And let's say the security or the distributed firewall rules keep the same wherever the VM is placed, right? So we will focus this use case in this case in the security groups, the distributed firewall rules, and how we span it across locations, right? So First of all, just let me explain you a few concepts. And here you can see that the groups can be global. When I say groups, I mean security groups. It means that we group the objects that they can be located everywhere. Right, everywhere the VM is placed, it will be added into the security group if the security group is global, right? So the groups can be region. It means that it's a scope. It's limited to a group of locations or a simple location, right? When you create or when you prepare the federation, each location it's a region, okay? And at the end, it can be local. So the scope of the group, as you can imagine, it's only the location where it's defined. It's the local groups are the groups when you create it through the local manager. Okay. So what happened with the distributed firewall rules? So you can combine all security groups between each other. You can create firewall rules between local groups and global groups, from global groups to regional groups, from regional groups to local groups, whatever you can imagine, right? And the most important that it can be dynamic, right? By tags, for example. So this is a really cool thing. Any question so far? Any doubt that you want to comment? Feel free.
So far, there are no questions.
Okay, thanks, Tina. So let's jump to the demo. So yes, I have videos like Bassem, but I have the lab as well, because at the end we will check it live. But let's move on first with the video. So yes, as you've seen before with Bassem, we have two sites with one VM per site, Web 01 Amsterdam and Web 01 Utrecht. And it simulates an application spread across location. If we go to the local, let me stop it. Let me pause it. We'll log it into the global manager. Sorry, first of all, in the local managers, in the Utrecht, for example, just to check that we have a pre-create tags. One represents a site. Here you can see the Utrecht UTR, and the other one represents a tier, right? I have the same tags on every location, okay? So here we have the Utrecht, and here we have the Amsterdam tags. Keep in mind that we are in the local manager right now. So with that, we'll go to the global manager, and here we will create the security, the distributed firewall rules. Okay, but for the first step, we need to create the security groups, because we will create the security firewall rules with security groups. So here we will create 3 security groups. One, as you can see here, the global security group. The region, you can see that it's the scope, it's global. And we will define the criteria of VMs that will be part of that group, right? Here we put based on tag and contains the word web. Okay, save. We'll create another security group. That the following one is just local, or let's say region, because as you remember, a location from global manager, it's a region. It's called a region. So with the same. The difference here is that we'll create a criteria based on 2 tags. The tier tag, and the reason of that group is local. We include also the site tag, in that case, Amsterdam, AMS. Okay, and we will do the same with security group of Amsterdam. Let me speed up a little bit because we don't have a lot of time. Now we have the 3 security groups, and we will go to a security distributed firewall to create the distributed firewalls. Here, as you know, maybe you don't know, NSX introduced the concept of category within the distributed firewall. So we will create in the application category, we'll create the application section, right? Here we will add all the firewall rules that applies specifically to my application. And as you can see, the section is global and applies directly to the NSX web tier global group. This is the parameter applied to is critical for distributed firewall of NSX, right? Because it makes it scalable. If we let this parameter as the default in a distributed firewall, the distributed firewall rules gets unmanageable. So here we create an ingress rule that it allows, for example, ECMP and HTTPS. This is, for example, this is a front end of my application. Okay, take a look at any source to my security group, global security group. It allows those services, and at the same time, we will create an egress rule just to allow outgoing traffic from my application. So let me speed up a little bit. Here, take a look. Here I have the application section, and now I'm gonna create an infrastructure rule just to show you local sections, right? So imagine that I have in Amsterdam, I need to create rules for my infrastructure, and here we have to allow DNS and NTP and Active Directory. And for example, in Utrecht, I have those 3 services plus backup, for example. So this is the way that I will show you once you migrate VMs from one side to the other side, imagine for a DR or just workload movements, then the VM keeps the global rules, and the VM will receive, when it's moved to the other side, will receive the infrastructure side for the specific site, right? So here we will create the infra rules for the track. We have 8 minutes. Let me speed up a little bit, and I will show you all the roles. Hold a second. Sorry. Here. I have in the infrastructure category, I have two sections. One section for Amsterdam that applies only to the Amsterdam and applies to two different groups, Network and Security Group Web Tier Amsterdam and Infra Amsterdam. And the other section for Utrecht applies to only Utrecht site and the two groups, Network and Security Web Tier Utrecht and Infra Utrecht, right? So let me show you. Yes, maybe here is better to show you the whole configuration. Here I have at the bottom, I have the application section, lab app, where I have the firewall rules for my specific application, that we have in the lab, and the other two are the infra sections. Okay. Here, I would like to show you that you are able also to go to directly on the local manager, and there you will see the application section. Here you can see the application section, lab app, and the infra section. Keep in mind that we are in Amsterdam, we see only the Amsterdam section. If we go to Utrecht, we will see only the infrastructure Utrecht section and the application section. Okay. And at the end, in the video, in order to apply the security on the VMs, we have to assign the tags, right? If we go to Amsterdam, we will see the two tags, and we will assign those tags to the VM that is placed in the Amsterdam site, right? So the VM will receive the tag of the tier and the tag of the site. At this moment, the security is applied on the VM BNIC. We do the same in the Utrecht site. Be aware that everything is done through the global manager. And that's all. I would like to show you now directly on the lab. Okay, let me log in. I'm logging to the vSphere. Here I'm logging into the global manager. Here in the vSphere, we see that we have the Web 01 Amsterdam and Web 01 Utrecht located on each site. And just to show you, this VM is located in the first host in the 20, and Utrecht is located in the 22, right? Because I would like to show you how to review the security firewall rules directly from CLI, right? From CLI. Here, as you can see, let me move that one. Here we are in the host 1 of the site 1, right? Here I can run the summary. Here what I'm seeing. So here's the name of the filter in the VM, right? Here I have the VM Web 01 Amsterdam, and here is the name of the filter. It's the name of the BNIC, right? The firewall that it's located in the BNIC. And keeping just to take the note of this number, because if I go to the NSX CLI, here in the host. Remember that I'm in the ESXi host. If I run the get firewall, BC. Here I have the same information more or less, but I need to copy this ID, the virtual interface ID, just to run the get firewall. So here what I see. Remember, this is the firewall rules for the infrastructure side, the specific infrastructure rules for the Amsterdam, and I have the same, but for the application section, right? If this, if you see these IDs, is the IDs where that I can see in the security part in my global manager, right? Remember,
we have a question in the chat. Do you want to take it now, or do you want to take it quickly at the end? Because we're running.
Let me finish this check, and then I go with the questions. It's okay.
Yeah, it's fine.
So yes, here I have the Amsterdam side, and here I don't run. I am not going to run the same command again. But here we have the firewall for the Utrecht side. Remember, here I have DNS, NTP, and Active Directory. Here I have DNS, NTP, Active Directory, and backup. Okay. And this is for the Web01 Utrecht. Let me do one thing. Let me simulate a DR. Here is just a vMotion because we have the vCenters in linked mode. But it could be maybe with SRM or some other DR orchestrators. What I've done. It's working. Something is wrong in the lab. Cool. Okay, perfect. The VM has moved from site 1 to site 2. If I go to the ESXi host and I run the same command, take a look. The output is nothing. Why? Because the VM doesn't exist in that host. So the VM has been moved to this host, right? To the second site. Here I have the rules of the VM Web01 Utrecht. And let me show very quick. Take a look that here I have both VMs, Web01 Amsterdam and Web01 Utrecht. I need to take a note of this number, 273, NSX-T. I will do the same. So get remember 273, this one 273. So I get this virtual interface ID. Take a look. Let me do the same because it's quite important with the other VM. take a look here. I have the application rules the same on both VMs, regardless the VM1 has been moved from site 1 to site 2. So we keep the security stuff. But here I have the infrastructure rules in the VM web 01 Utrecht, but I don't have the infrastructure rules in the VM that has been moved. So it's why this fact, why this behavior, right? The reason of that is the tax. If I go to the Utrecht local manager in the inventory tags and in the Utrecht site, the tag of Utrecht site, I include the VM that I just already moved. And I run the same command. Remember, the number is at the end of 962. So 962, the section, the local section has been applied. So it's really easy to do a DR of the workloads, and during the process of the DR include some script that just add the tags of the target location, right? So, and when the VM brings online on the target site, it brings up with all the security stuff. So that's all. Let me, any question, any doubts? We have a question, right, Tina, in the chat?
Yes, we have one question, and it says, can that NSX tag assignment be automated tagged via Vera during provisioning?
Exactly, yeah. This is one of the main use cases in the BRA, that when you create or you deploy workloads, you directly assign the tags that your infrastructure needs. So you can create, it's common that in the VMs have 4 or 5 tags, one identifying the environment, the site, the application, and the tier, for example. So when you deploy the VMs from BRA, it's really common. It's very common to assign the tags during that process. So yes.
And there's another one.
No. The tags that you have to use here is the NSX tag. It's not the same. Great. I think that's all. We have actually we had an extra slices for, but I think we are run out of time. So maybe we can, I don't know, we can share it to the rest of the team or later on.
How much more time do you think you need to show what you still have planned?
No, much more than 5 or 10 minutes, maybe. Let me show you just this one. The federation requirement, right? I think it's quite important. As you've seen during this session, the production ready release of NSX-T is 3.1. So you have to be at this release for the global manager and local manager. The latency between sites should be less than 150. Of course, connectivity between local managers, global managers, and edge nodes must be without NAT, and obviously without firewalls, or at least allowing the management traffic. There's no one requirements, the one bandwidth requirements. There's no one MTU requirements, although 1,700 it's a recommendation or plus. And for the data plane recovery, if we have different providers on different sites, so we have to take care of it, because the subnet will be advertised on both sites. So it's a specific configuration that requires attention here. And that's all. I think this is the most important in the backup slices, and that's all.
Then a big thank you from my side, Pep and Bassem, for taking the time in sharing your knowledge about NSX-T. Thank you for everyone who stayed over the hour. And yeah, see you next time. See you in 2021. So as this is the last TAM Lab for 2021, Merry Christmas to everyone and have a good move into the new year. And see you all in 2021. Thank you.
Thanks, Tina. Thanks, everyone.
Thanks, Tina.
Cheers.
Thanks, everyone. Thanks, Bassem.
Bye-bye.
James.
Thanks.
Bye-bye.
Cheers. Bye.